I don't know. I don't know what he's doing. That's also kind of dumb.
All right.
Sorry.
Hey everyone, welcome to the last meeting of the spring semester for 2022. We're just going to go over basic assembly that we've made for the joystick. It's not the actual joystick assembly itself, it's a breadboard version of it. And we're also going to go over an example code that we have used from the Arduino website to use the joystick module to make a servo move. So, and then we're going to slightly talk about the upcoming semester plans. So, all right. So to test the joystick, basically at the bottom you see a picture of what we have just made. I actually have the assembly right here. If you see, let's orient it. There you go. So we just made this within like 30 minutes. But basically what we did was try to find a similar code online to just test on one servo instead of, you know, all the 10 that we have. And here's the link I've also provided in the slide. I'm going to provide that in the Discord as well. So this is the link that we used to basically assemble and you know, code the joystick itself. They use an Arduino Uno, but it works the same with an Arduino Nano, and it's basically the same pin layout. So the pin layout is laid out over here. Again, if you kind of see like orange pin 9 for the joystick. So no, hang on. So if you look at the joystick right here, so we say ground pin 8-3. So we look at, let's see here. We look at ground right here, and then so that's blue, and it goes to, it's connected to A3. If you, I know it's kind of hard to see, but this is A3 and this is corresponding with A3. That's I mean, based on the Arduino workshop, y'all should know how the pin layout work by now, but this is just in case you want to see. So y'all can use this if y'all want to have your own breadboard, if y'all want to come here either before the end of the semester during open lab or next semester to test out your own. You can, you're more than welcome to, or you can try Tinkercad if you don't have the materials. All right, so this is the code I use, and then so I opened it on Arduino, and then got to make sure you set, but apparently this Arduino Nano is an old breadboard. So when you set the board, you go to type Arduino Nano, and then the processor, you say old breadboard, specifically for this one. You'd have to look more into it depending on what you have, and then the COM ports. So, and then, so basically what this is saying is it layouts your pins, and then right here is the communication rate of the joystick module to the Nano. So this is just saying how fast is it communicating. And then here you lay out the pins to what's output, what's input. So if so this starts high, and then you attach the servo. So the analog read, which is what we set right here, is basically going to say whether the joystick is moving up or down. So let me show you. Well, I'll explain this first. Basically, the joystick starts at a standard communication rate of around 500, and then whether you move it right, it goes up. Move it left, it goes down. And based off of that number, it gives a set position for the servo to move to. So basically, this is what the joystick will read, and then it will say that the serial number is now that reading, and then it's putting it into a converter. Basically, you're just converting it right here into degrees, which is the position we're trying to get for the servo. And then, yeah, basically it moves the servo in that position. So let me show you what I'm talking about right here. All right, so we can see here, actually, let me do something better. Let me put out the reading for this. So let me stop it real quick. What you can see right here is the input from the joystick is just 500. That's basically like saying 500 communication rate, around 511. And then the output of the servo is a given position of 103 degrees. So that's its set position at the moment. So now we're going to try to move the joystick to the right. And what we see is that the input from the joystick went up. So if we can go back and check that out. Yeah, right here. So I moved it to the right, therefore increasing the communication rate of the joystick with the Nano, which basically doubled. And in basically through this code right here, it converted that into a greater degree that the servo should be in the position. So as you can see, it moves from 103 degrees to 154 degrees because I increased the output of the joystick. And then if we move it to the left, so I'm just going to move it to the left, that will decrease the input rate from the joystick, therefore decreasing the degrees that the servo will be positioned at. So pretty cool little thing. That basically explains the whole code. If y'all want to test it out, again, you got Tinkercad. If you have your own materials or you want to use the lab, just let me know and we can try to basically remake this together. But this is kind of the concept of how the coding of the joystick will actually work for using the bus linker servos. So we'll see. And then again, the code's provided in the slide, and I'll post that in Discord. Let's see. Let me know if y'all have any questions about that. Just you can get to me on Discord. All right, so for the fall 22 semester, currently we have got some material that we have ordered. We are still waiting, but throughout the summer before fall starts, we should have everything. My plan, so this is what we currently got. Battery case, we got some bearings, we got buck converters. We're almost there. But if we do get the PLA filament and PETG filament during the summer, I am planning to come here and start printing those because it's going to take quite a while to print everything that we need, specifically the PETG stuff. Well, considering that everything's PETG, it's going to take a while. I'll announce those times whenever I go. It's most likely I'll be here around June and July printing the stuff. I'll be on vacation during May. And then I'm planning to have our next meeting for the fall semester on August 26th at 3 p.m. That's not a set date. It's just it's basically the first Friday of the first week. And then we can try to adjust it based off everyone's availability. I'm going to ask you guys during the first week if you are available that time, and we'll get a meeting set. So once we do have all the material, first of all, make sure that you had your machine workshop training done because we're going to need to start cutting, specifically the aluminum extrusions, the shaft, and then I would still like to do a lathing workshop if they have it available early during the semester. If not, we'll just get someone in makerspace to help basically lathe the shafts to get those indents. And then this is basically what the building is going to revolve around. So I made a building diagram on diagram.net. I couldn't find a better way to do it. You would have to, if you want to check this out, you would have to download the extension for Chrome for diagram.net. If you do have any questions on that, I can try to make a PowerPoint as well with all this stuff. But basically, this is just connecting GitHub to what we need to do. So as you can see here, so at the top, you basically have the category that the building will revolve around at that specific objective. So first is cutting and refinements, 3D prints, which I'm hoping to do over the summer, phase 1, 2, 3, 4, and 5 assembly. So the phase depends on the past phases to start. So basically what we're going to do at the beginning of the semester, if we have everything, we're going to size and cut the aluminum extrusions and shafts. And as you can see here, if you do have access to this, you can just click on the actual objective and it'll provide you the link to the instructions on the GitHub to basically get the specifics. So as you can see here, it tells you the size, where to put the indents and stuff like that. So basically, and that's for everything, every little slide here. So yeah, sides and cuts, cut the aluminum extrusion beams, and then hopefully get started on the servo coupler bracket, installing heat inserts. We still need to go over that. We'll probably just go over that during the assembly. Printing knuckles, cleaning up the insides of the 3D printers. I'll probably do that during the summer. Anyways, so the light blue is the phase 1 assembly. And then after we finish phase 1, we'll be able to go to phase 2, which is the yellow. So as you can see, I think this would be the easiest to start installing shafts, the coupler. And eventually we can move to the driver assembly once we get the knuckles and the wheel hubs. So we can start moving on to that. Or we could separately choose to work on this before starting the drive module assembly. If we get these 3 things done, we can start working on the pivot joint assembly and so on and so forth. So the way I'm hoping to do it is we go by color, basically, just because at the end, things start getting mixed up. Like we should start with the blues and then go to yellow and then go to orange and then blue, and then this is blue red. The only reason this is a mix of the 2 phases is because the differential assembly is part of the suspension assembly, which connects to the drive frame. And those are basically dependent, but we'll basically be doing both body assembly and rocker assembly like very close to each other. So it's not that big of a worry. But yeah, you are free to check this out. If you don't have access to this, again, the instructions are basically on GitHub. The way I found these links, again, I just go. So here's the main Sawppy Rover link, and then you go to docs, and then so down here is the details for assembly. It's right here, servo actuator, wheel drive modules, and so on and so forth. You can also just go straight here if you don't want to like try to look at the instructions down here. They're provided right here. So assemble module actuator, body, bogey, and all that stuff, all that good stuff. So yeah, just prepare for that. For next semester, that's going to be our main focus, and hopefully by the end of next semester we'll have everything finished. So, and then hopefully we're gonna try to see if we have enough interested people for the University Rover Challenge. So that's an announcement coming up soon. But I'm hoping we could use the rover that we built to actually become part of the University Rover Challenge. So it would be really nice. But other than that, yeah, renting will occur over summer. And that's basically all I got for y'all. Sorry I couldn't invite y'all to the Zoom meeting. We were having trouble trying to assemble this in the first place. But we finally got it together. So I'm gonna leave it as it is in the Rover box in case y'all just want to come in, test it out, just see what it does until next semester. So yeah, thank y'all for joining, and I'll see y'all next semester. Good luck on y'all's exams.